Hello, my name is Alex Velasquez, and I'd like to give a presentation on alternating current and its similarities to woodworking. So, what is an AC circuit? An AC circuit, different from a direct current or DC circuit, it has current that flows in alternating directions. So, rather than like a DC circuit that current flowing in only one direction, it is constantly fluctuating from left to right. And so, objects flicker to save energy. And so something powered by AC circuits is constantly turning on and off as a means to save energy. And so my background in woodworking is my dad has always been a handyman, and he loves to fix things around the house. He says he'd rather do it himself than hire someone to do it. And I sometimes help out with his projects, and he even has a landscaping business that I work in. And so that's a lot of where my interest comes from. I also took a woodshop class in middle school, which really introduced me to the basics of everything. And one thing I noticed was the hand saws, they have three different varieties. You have a hand saw that can cut on a pushing motion, a hand saw that can cut on a pulling motion, and then a hand saw that can cut on both, that cuts on both pull and push. And so, having a saw that cuts in both motions of pull and push usually ends up with a quicker cut. Um, and so AC current explanation. So unlike AC, DC circuits have a current that flows in a single direction, as previously stated. And so the fluctuating current in AC circuits allows the similar amount of energy to power objects for a longer time without wasting that energy, right? And so light bulb in AC isn't always on. It flickers on and off as the current keeps changing direction. And using that method, it's able to use a similar amount of energy as a DC circuit, but keep it on for a lot longer. And the flickering is so fast that our human eyes can't even perceive it, so it's not a big issue for us. And the current in AC can be represented by a sine graph. So the current, imagine in an AC circuit, as it reaches its max current and then changes direction, and then reaches its max in the opposite direction before it changes direction again. If you were to graph that out on a piece of paper, you'd notice that it makes that graph of a sine wave. And because it's fluctuating current, standard DC equations don't work for AC currents. And so that's where we get the equation of voltage equals V naught times sine WT and current equaling I naught times sine WT. And so these are the basic equations for voltage and current that are used to find other equations. And so how does woodworking how is woodworking similar to AC? Well, hand saws, like I said earlier, have three basic varieties. And so saw that cuts in wood motion is most similar to like a DC circuit, right? When you cut with the saw on the push or pull, you have to then take the saw and reset to its starting position. Similar to how a DC circuit, once the current goes out one side and lights the bulb, it has to return to the other side of the battery in order to start again. Um, but an AC circuit is more like a saw that cuts in both motions, right? You push forward and you pull back and you're cutting in both motions. You don't have to constantly reset to its starting position. And so that's similar to an AC circuit because the AC circuit is constantly changing direction. And so the saw that cuts in both motions changes its cutting force it changes the direction of its cutting force, similar to how an AC circuit changes the direction of its current. And that is everything I'd like to say. And thank you very much for watching.